Hi, I received a lot of emails you guys asking for help on section 2.4, so I decided to make a short video to explain the important concept for this section. Um, so I'm using three homework assignment problem to as an example to help you for this section. So just a quick recall for f of t, f prime or f double prime. F of t is just a normal function. It's the value of the function. And f prime of t, or the first derivative or the rate of change of the function f of t, or the slope of the function f of t as a given point. The second derivative is the rate of change of the first derivative or f prime. It's also the slope of f prime as a particular point. Now, the first question here, they give you the table and they ask you whether this one has a positive or negative, the first and the second derivative. Here we can see 150 go to 145 is decreasing. The rate of f of t or f prime is decreasing here, and 145 go to 137 is also, the rate is also decreasing, or f prime is also decreasing or negative here. 137 go to 122 is also decreasing, so your f prime is decreasing. 122 go to 98 is also decreasing, so your f prime is decreasing or negative. That's why your first derivative is negative for sure. How about the second derivative? How do I see from this table? Now, if you look carefully here, 150 go to 145. You are decreasing as minus 5 units from this point to this point here if you increase the time by 2 seconds. Now, if you increase the time by 2 seconds, the same interval again, but you are getting subtract 8 from here to get to 137. And then the next one, you have to subtract 15 to get to 122. And you have to subtract 24 to get to 98. And you have to subtract 42 to get to 58. So you can see that it's decreasing, but it's decreasing as larger and larger and larger in the negative value. That means that the rate of change of your f prime is more negative. That's why the second derivative is negative. The second derivative is the rate of change of your first derivative, and the first derivative here you can see is minus 5, and it's go larger in the negative side, minus 8, and it's go larger in the negative side. So that's tell you the second derivative is going to the negative side. So that's how you find the second derivative or the f double prime to be negative, because the negative number here is keep getting larger and larger to get to the next one, which is your f double prime. Now, how do I find f prime of 2 and f prime of 8? Again, this is just the slope formula, and we can use the slope formula to estimate f prime of 2. I take 2 and the next point here. So I take 137, and then 2 is 145 over the changing in t, or 4 subtract 2, and that should give me minus 4 around that. Now to find f prime of 8, so I pick 8 in the next point, so that should give me the changing in y of 56 subtract 98 over 10 subtract 8, and that should give me around minus 21. Okay, so let's go to the next question. I think this question we already went over this in the lecture, but let's go over this again. Okay, so we are given the function f of t, and you are asked to label the side for f prime and f. I think this is f double prime. Let me double check here. It's very small, so I can see. Okay, let me go back to the okay, this should be f double prime because we already have f prime here, so that should be the mistake here. Okay, it should be f double prime here. Okay, all right, so let's see here. We know that this is the f function, right? This is the f function, and the value for a, because a is a little bit below the x-axis or negative value, b above the x-axis, so it's plus, c is also some positive value here, so also plus, and d is below the x-axis around some negative value, so that's this negative here. Now for f prime is the rate of change of this function or the slope of this function, and that's a. We can see that the slope is constant or 0. The same thing to b, this is also constant or 0. However, at c, if you draw the tangent line to estimate the slope, you can see it's going down or negative, decreasing, and d is going up here or plus. Now for the f double prime, remember we have the rule for that. If we have the plus, then it should be concave up, right, the happy face, and concave down when we have a negative side. So if you go back to here, we have something open up or concave up at a, which is the plus or the positive second derivative for the function f. Now for b, it's concave down as point p, or you have negative side. Again, c is also on the way of concave downward, so it's negative. And d again is concave up for the graph, which is positive here. So that should be how you find f prime and f double prime for the size. Now let's try the last problem here. A lot of you also got problem for this 24 here. So let's read the question carefully. For 3 minutes, the temperature of a furious person has had a positive first derivative and negative for second derivative. Now, which of the following is correct? Okay, so let's draw some picture here. We have positive first derivative, so let's just say f prime of t, which is positive or plus, and the second derivative or f double prime of t is negative, so this is negative. Okay, so f of t is positive. It's telling you that the slope of the normal function or the temperature, right? The function temperature here is f of t. So if f prime of t or the first derivative is positive, it's telling you that the function f of t is increasing or the temperature is rising. So in this case, we have is grows in the last minute, it grows here and also grows here. So we know that this is saying that it's failed, and we can eliminate this one right away because it should be something rising. So only A, B, or C that is correct. So C is not correct right away after we take care of the first condition here. Now, so we know that is the slope f prime of t is increasing, right? You have some increasing function, or your temperature is rising, right? Let's consider the next condition. We are given for the second derivative to be negative. So as I told you before, when the function has a negative second derivative, that means the function is concave down, right? is concave down. And we know that's because the first condition is saying that the first derivative is positive, or your function is increasing. That means we are only considering this portion because the function is now increasing. Okay, we know that's from the first condition that is increasing. That's why we take the first portion of the concave down to represent for the problem here. And from the information here, if the negative second derivative, then we know that we have the concave down. Even though the function is increasing, but it's concave down, that means it's telling you that the temperature is increasing, but it's increasing at a slower rate because it's concave down. It's going down again, right? That means it's increasing, but it's increasing at a slower rate compared to any of the previous minutes. So your correct answer should be B, because the temperature does rise in the last minute. However, it is rising at a slower rate or less than it rose in the minute before that, because it's rising, but it's rising at a slower rate due to the negative second derivative here. If you check back to part A, it's saying that the temperature is rising in the last minute. However, it's more than it rose in the minute before, which is not correct. For concave down, it means that the function is rising at a slower rate as it moves forward. So A is not correct. And this one, the temperature rose for the 2 minutes but fell in the last minute, which is also not correct, because we only considering 1 minute in the last minute and then the one before that. You cannot say that it fell in the last minute and rose at the same time. We cannot have that. We are increasing, but increasing at a slower rate, not rising and falling at the same time. So which is not correct for this one. So the temperature does rise here, but it's rising at a slower rate. That means the last minute you have your temperature rose, but then before that is higher, or is the last minute is less than the minute before that, because it's rising as a decreasing rate due to f double prime less than 0. I hope this helped you for this section, and thanks for watching.